This is the second lesson about continuous functions. There are two graphs, as you see. These two graphs represent the removable discontinuity. So removable discontinuity is either like graph 1 or like graph 2. So what do we know about these two graphs? It is obvious that in these two graphs, limit at a does exist. So limit at a does exist. However, there are two scenarios about f of a. So case 1, f of a is undefined. Which is graph number 1. As you see, there is no value for f of a. And in case 2, f of a is defined by, but f of a is not equal to limit of f of x as x approaches a. So in these two scenarios, we call point with the x coordinate of a removable discontinuity. So f has a removable discontinuity at a. So again, f has a removable discontinuity at a if limit at a does exist, but there are two cases for f of a. F of a might not be defined, or if it is defined, it's not going to be equal to the value of the limit. So let's have another example. So suppose that f of x is x squared when x is not 1, and at 1, x squared is defined to be 2. Okay, I want to know if 1 is a removable discontinuity or is not. So I'm going to calculate the limit when x approaches 1. So limit of f of x as x approaches 1 is 1 squared, which is 1. And f of 1 equals 2. As you see, the y value at 1 is not equal to limit. Therefore, function has a removable discontinuity at 1. I'm going to sketch the graph. So we have x squared everywhere except at 1. So this is x squared defined everywhere except at 1. At 1, the y value is defined to be 2 according to the function given. So 2 is here. There we go. So as you see, a point is removed from the graph and is called removable discontinuity at 1. So let's have another example. F of x equals x minus 1 over x squared minus 1. So the question is that what discontinuities this function have? So of course, everything starts with factorization. So we set the denominator equals 0. Either x minus 1 equals 0 or x plus 1 equals 0. So x equals 1 or negative 1. So if you cross out x minus 1, what remains is x plus 1. So the denominator that stays after simplifying, which is x plus 1, gives you a vertical asymptote. So it means x equals -1 is a vertical asymptote to this function. But the one that you canceled, which is x minus 1, if you set it equals 0, you get the removable discontinuity. So for the removable discontinuity, we can show the coordinates. X is 1, and then if you plug in x here in simplified version, if you plug in x1, it's going to be 1/2. So the coordinates of the removable discontinuity is 1 and 1/2, and the equation of vertical asymptote x equals -1. Again, so first you simplify. Those denominators that remain after simplifying, they give you the vertical asymptotes, but the one that you canceled, they will give you the removable discontinuities. So let's have another example. F of x equals x squared minus x, and then x squared plus x minus 2. So let's factor everything as much as we could. Okay, so you can cross out x minus 1, and what remains is x over x plus 2. Set the denominator equals 0, the denominator that stays after simplifying, so x plus 2 equals 0. Then x equals -2. This is the vertical asymptote, obviously. The one that you canceled was x minus 1, set it equals 0, and x equals 1 is the x coordinate of the removable discontinuity. To get the y value, you put it in here into the simplified version, and it's going to be 1/3. This is the removable discontinuity. So removable discontinuity and the vertical asymptotes, they are both discontinuities. They are two types of discontinuities. So other than removable discontinuities and vertical asymptotes, we have another type of discontinuities, which is called jump discontinuity. So look at this function. So here is 2, here is 1, here is 3. So left limit at 2 equals 1, and the right limit at 2 equals 3. And we know that as soon as a limit does not exist, function is not continuous. But since the left and right limit both are numbers, but they are not equal, we call this type jump discontinuity, because it jumps from the y value of 1 to 3. So f has a jump discontinuity at 2. So again, if we categorize our discontinuities, first we have removable discontinuity. What is the definition? The definition is that the limit exists, but the y value either is undefined or is not equal to the limit. The second type is the vertical asymptote, and the third part is jump discontinuity, when the left and right limit, they both are two numbers, but they are not equal. That's it. This is the second lesson about the discontinuous points and functions.